Hello everyone, welcome back. It's been a while since my last video, so thought of starting with another fundamental topic. Today we are going to talk about something every software tester should understand, no matter how experienced you are. The 7 software testing principles. You may have heard these in ISTQB training or interviews, but don't worry. I'm not going to just read definitions. I'll explain what they really mean, why they matter, and give you some simple examples you will actually relate to. So, let's jump in. Before we look at the principles, let me ask you something. Have you ever heard someone say, "Did we test everything? Why did this bug go to production? Can we guarantee there are no defects?" Testing principles exist because of questions like these. They help testers make better decisions instead of relying on guesswork or assumptions. They also support risk based thinking, which means we focus our effort where failures would have the biggest impact. And the best part is these principles apply to any development model, whether your team follows Agile, Waterfall, or DevOps. Without these principles, testers may try to test everything and still end up missing the most critical defects. Let's start with the first one. This principle simply says testing can find defects, but it can't prove the software is perfect. Even if all your test cases pass, it doesn't mean there are no bugs. It only means that no bugs were found in the scenario you tested. For example, you test a login feature. Valid login works. Invalid login shows error. Looks good, right? But what happens if the internet drops while logging in? Or if the user is on an old browser? That's why we say testing reduces risk. It doesn't eliminate it. This one is very important, especially for beginners. You cannot test everything. Not because you're lazy, but because it's practically impossible. Think about it. Different devices, different browsers, different users, different data combinations. The number of possibilities just explodes. So instead of testing everything, we test what matters most. For example, in an online shopping app, checkout, payments, order confirmation, those are far more important than testing every button color. Now, this principle is a lifesaver. The earlier you find defect, the cheaper it is to fix. If you find a bug in requirements, it's cheap. In development phase, more effort is required. In production, it's very expensive. That's why testers should be involved early, not just at the end. For example, if a requirement says password must be secure, a tester should ask, what does secure mean? Is there a minimum length? Special characters? Catching this early avoids confusion later. This principle tells us that bugs like company. In most systems, you will notice that a few modules have lots of bugs. Other modules have very few. Usually, complex or frequently changed areas cause more issues. For example, if the payment module keeps breaking, that's where you should spend more testing effort. So, instead of spreading effort evenly, We focus where risk is highest. Have you ever run the same test cases again and again and found nothing new? That's because tests were out. Once bugs are fixed, running the same tests won't reveal much more. That's why we update test cases, add new scenarios, or do exploratory testing. However, running the same tests still makes sense in automation, especially for regression testing. So the idea is repeat tests to catch regressions, refresh tests to find new bugs. This principle reminds us that there's no universal testing approach. Your test basically depends on what kind of system it is, how risky it is, who the users are. For an example, banking apps focus on security and accuracy. Medical systems focus on safety and compliance. Mobile apps focus on usability and devices. So, when someone asks, what is the best testing approach? The correct answer is, it depends. This last principle is a very important one. Even if software has no known defects, it can still fail. Why? Because it might not meet user needs. It might not solve the right problem. Or it might be hard to use. This is where we talk about verification and validation. Verification is, are we building it right? Validation, on the other hand, is, are we building the right thing? A feature can work perfectly and still be rejected by users. So, to wrap things up, the 7 testing principles remind us that testing is really about managing risk, not chasing perfection. They teach us that we can't test everything, that finding defects early saves effort, and that some part of a system will always need more attention than others. They also remind us to keep our tests fresh, adapt our approach to the context, and more importantly, focus on whether the product actually delivers value to users. If we keep these principles in mind, we don't just test more, we test smarter. In real projects, being a good tester is not just about writing test cases or finding bugs. It's about how we think. A strong testing mindset means focusing on risk instead of trying to achieve perfection. It means asking questions early, collaborating with developers and stakeholders, and always keeping the user's experience in mind. Great testers don't just check if the software works. They think about what could go wrong, what matters most to the business, and how the product will actually be used in the real world. Because in the end, testing is not just about defects, it's about delivering confidence. So, those are the 7 testing principles. Simple ideas, but incredibly powerful when you apply them in real projects. If this helped refresh your understanding or clarified anything, I would love to hear your thoughts in the comments. And if you enjoy content like this on software testing, automation, and QA mindset, don't forget to subscribe so you don't miss future videos. Thanks for watching and happy testing.